Next up, we are going to be hearing from Pavel Kudinov from the Pagoda team on utilizing near blockchain data for dApps and analytics. Did
The mic? Can you hear me, guys? All right. Good to see you all. Thanks for coming. Uh, I'm very excited to talk about data. I'm working at Pagoda. I'm the engineering manager at the data platform team, and we're looking after different tools for analytics and for developers to build rich user interfaces. I'm going to be talking about indexers today. So there is a little bit of confusion when people talk about indexing. What is indexing? It's actually a lot of different things. So as you know, blockchain is a stream of transactions, actually a stream of blocks, and every block has a bunch of transactions. But it's very hard to fetch some transactions in the past or make some aggregate queries on these transactions. To make these queries, you actually need to do indexing. But the catch is you need to do that differently depending on the use case you are solving. And I found through almost 2 years working in the space that there are two major use cases usually. And one is analytics. Let's say you're a product manager or a blockchain analyst and you want to see the behavior of users of certain smart contracts or certain apps, and you want to see this in time, and maybe you want to find some insights. So this is what we call analytical use case. And the other use case is probably more important to attract more users, is to build rich user interfaces. And for that, you need a different type of indexer, which is real-time and which gives you all information needed to show on the user interface. So let's talk a little bit about analytics first. And we recently released a public dataset on Google Cloud. This is supported by Pagoda, and this is updated near real time. And this is solving this analytical use case. Anybody can come in and build SQL queries to get different insights. We store and provide the full block data, all the transactional data, receipts, execution outcomes, and even parse near social DB data. So you can see all the content and query all the content generated on near.org and other gateways. One of the simplest use cases is to actually understand the number of users that interact with your smart contracts, right? So with this is a sample query that does that. I'll just quickly show you how you could use this query. If you go to docs.near.org and search for BigQuery, you will see a guide on how to use this. And here you can just click on the view the public dataset. This is my account on Google Cloud. You click view dataset. And you can just take this query that I had on the slide, and I'll walk you through this quickly. Oh, sorry. Paste it here and execute. So what it does is we're looking at all the receipt actions. So these are all the receipt actions. We are then joining these receipt actions with the transaction that this receipt is originated from. And if you analyzed near blockchain data, you know how sometimes complex that is, because receipts are executed in different blocks. So when you're looking at receipt, you don't necessarily know which transaction it was originated from. So for that, we created this table, receipt origin transaction. So we're joining on receipt ID. And then finally, we're joining this receipt, this data set with a transactions table, and to get the, by transaction hash, to get the signer. So this is what we're interested in, the signer who signed the original transaction that produced the receipt that interacted with, in this case, it's token.sweat contract. And I'm only interested in function calls and I'm only interested in anything that happened this month. And so as you can see, we have roughly 80 to 100,000 different signers daily signing transactions that interact with token.sweat contract. If you replace this with any other contract that you manage or contracts, you can use obviously things like statements, etc. You can build different insights. This is available for anybody to use. It is not completely free. It is free from Pagoda side. We're not charging for this, but you're charging, the Google Cloud is charging for compute. Every time you run the query, you need to pay for the service on Google Cloud. You can copy this data daily to your data warehouse. You can take the portion of this data, and we have some big companies already integrating it to their ETL pipelines. We are soon going to be adding more data to that, and we want to hear your feedback. What else do you want to see there? We're also looking at the patterns of data usage. But the things that are coming are fungible tokens, NFTs, and all the different events. So basically, if you want to look at the events, parsed events for your smart contracts, you'll just be able to make simple SQL queries directly on BigQuery. All right, so let's talk about rich user interfaces. Basically, what is that? It's allowing users to find the information on your apps, and I see designers smiling because designers always have a lot of things, a lot of ideas to show, to make the use of interfaces easier, right? But how to get the data there and how to get this data in the right shape and form and also make it up to date, right? So that's the real question. What are the common UI patterns that we have? So first of all, we want to show user-specific information. When we have a logged-in user, we want to show assets and information that they generated or that is relevant to them. We want to aggregate across multiple smart contracts. So for example, if you use a DeFi application, there might be multiple DeFi pools or lending pools, and you want to aggregate across all these smart contracts. And as new smart contracts are deployed and created, you want to automatically track these smart contracts too. You want to aggregate over time. So for example, you want to show weekly information or information for the past few days or monthly. And you might want to aggregate across users. So if a user has multiple accounts and they want to see information across all these accounts, you want to show this information together. You want to allow users to filter information. So let's say there is a history of transaction and they might want to filter by certain parameters. So filtering should be quick, which means you need indexes on these columns that you're filtering on. Of course, you might want to implement pagination because there might be too much information and you don't want to download all of it, which means you need efficient ordering. And of course, you want this data to be near real time, which means that when your users make the transaction and your user interface reads from your database, you want it to be up to date, ideally instantaneously, right? So how to achieve all of that? Well, actually, you need a database for reads. As you can see, we have a very happy user who uses NEAR blockchain, a dApp that is built on NEAR blockchain. It makes writes to NEAR protocol directly, which means sending transactions, signing and sending transactions through read RPC. And the blocks are then streamed. And then how to get them to the user interface? Well, you actually need to look at every block and write something that we call a projection. And then this projection is a piece of code that looks at every block, extracts information that is needed and relevant for your dApp, and puts it into the database, which we call the read database. And this is fairly traditional Web 2, so to speak, approach when you have a database specifically designed to serve queries that are needed for certain user interfaces. And you can build what we call materialized views there. And then this the user interface, the user, when they want to see something, they actually query from this database and not from the protocol itself, because making queries to protocol will result in hundreds or maybe thousands of RPC requests and making user interface very slow. So how to do that? Well, first of all, we more than a year ago, maybe more than 1.5 years ago, we introduced NEAR Lake that allows you to stream blocks directly to your server. You don't have to run a node. Running a node is very expensive. You need to maintain this node. You need to upgrade it. So if you don't want to do that, you can use NEAR Lake. It's a storage of all the blocks in JSON format. It is always up to date. It's less than 3 blocks away from the tip of the network, usually. It is roughly 25 times cheaper than running a node. It can stream 300, sometimes up to 600 blocks per second. And currently we have more than 50 indexers live on mainnet. Receiver pays, so this is AWS S3 receiver pays policy, which means we pay for storage for maintaining it, but whoever is running the indexer will need to pay for every query, for every download of this JSON block. And as I said, it's 25 times cheaper than running your own node. We have indexers live in JavaScript, Rust, Python, Go, and even Ruby. We officially support JavaScript and Rust, and majority of indexers are actually written in JavaScript. So how will the architecture look like with this approach? Well, we have NEAR Lake, which is an AWS S3. We then create here NEP 141 indexer or NEAR balances indexer. These are 2 standalone applications that just read blocks, receive blocks as they show up in NEAR Lake, process them. This is our projection. Process them, extract needed information, put in PostgreSQL, and then HTTP server, specifically written for this use case, is serving this data as users requested. We have this running as an enhanced API on pagoda.co. These 2 GitHub repositories have the source code for it. If you need tokens, history, balances, for NEAR tokens, for fungible tokens, for non-fungible tokens, this architecture is implemented in these 2 repositories. And on pagoda.co, there is an enhanced API that you can see live for yourself. This was one of the first implementations of production indexers that we had. But then, as we were building more and more indexers, we found that actually, first of all, this is the pattern that keeps repeating. It's almost always the same pattern. And if you run multiple indexers, you need to look after the architecture, the infrastructure, sorry, of these indexers, and you need to make sure that they're not failing, they're not lagging behind, and the API is always live. So we find that this is one of the best practices to have the database optimized for the use case and to have GraphQL ideally automatically generated after your schema to make sure you do fewer queries to the API. And then we thought, well, developers want to build apps faster. They normally don't have database engineers in the team. They normally don't have time to build a proper architecture right away because they need to show traction to their investors, so they want something quickly. So we started working on Query API. It's a fully managed serverless indexers and storage and GraphQL endpoints. This allows you to create an indexer without maintaining any infrastructure. This is what it means serverless. We do have servers, of course, but you don't have to worry about them at all. We are auto-provisioning custom indexers for you. This is not a specific indexer for, let's say, tokens. This is the indexer that you need for your specific set of smart contracts. So without Query APIs, you had to build smart contracts. The data from smart contracts comes to NEAR Lake that I described before automatically. Then you need to create a database schema. You need to write the JavaScript or Rust code to process every block. Then you need to run a database instance, and to manage this database instance, you need to run an HTTP API server. You actually need a load balancer because if you have a spike of transactions, you want to scale this and you want to serve this traffic. And ultimately, you need probably to do some client-side transformations if you build REST interface, as people usually do when they build these APIs. So with Query API, all you need to do, besides your smart contracts, of course, is to think about the SQL schema and the JavaScript code that reads every block and transforms data from this block into the schema that you just created. All of the other components are provisioned automatically by the service. So this is a I want to show you a live demo, but this is a screenshot of a DDL schema for the NEAR.org main page social feed. It is powered by Query API today, and this is a couple of tables, actually 3 tables for posts, comments, and likes. Fairly standard Postgres schema. So you just create this right in Query API. After that, you write JavaScript indexer logic to process blocks as they appear. And then after that, you have automatically provisioned GraphQL API to access these data. So what is the workflow? How do you work with Query API? What is the process? So first of all, you go to designs. And once you have the designs, the user interface that you need to implement, let's say as a front-end engineer, you look at all the screens and you think of these screens and think of what are the queries need to be made to the backend to receive this information. And you want to actually have fewer queries on every load of the screen, right? So you need to design database after the schema that is needed to show, to implement the Figma prototype, right? So you create this SQL schema, and then you find few block heights block numbers, right, that you want to test on. And you write JavaScript code to inspect those blocks, extract the information. You can even debug this code right in the browser. I'll show you in a couple of minutes. Then you store the code and you watch the logs. The code and the schema is stored on NEAR blockchain. This is the storage layer for Query API. And then after a few minutes, the infrastructure will be provisioned for you, and you will see the logs, and you will have the database and the API. Obviously, you might face some bugs, and certain things won't work right away, so you'll go back and fix those bugs following your own logs. And then after that, once everything's working, you can go to Graphical Playground and generate queries and export them. So when you're creating an SQL schema, you need to try to design it for upserts, which means you might want to re-index your data. You might want to rerun your indexer from scratch, and your schema should support that as well as the code. To make GraphQL work well and efficiently, you need to create foreign keys. You shouldn't forget about indexes to ensure that the data, there are no full scans when you're querying the data. And sometimes you might want to show some aggregated data, let's say group by date or group by week. So for that, you can use views, and GraphQL will automatically generate a special query for these views. This will reduce the amount of code you need to write in JavaScript. So when you're writing the indexer logic code in JavaScript, we're providing a NEAR Lake primitives library, which allows you to extract data from the block easier with fewer lines of code. You still get access to the whole block. You can extract the receipt args, arguments, outcomes, receipt outcomes, events, everything that is stored in the block. And then you can use a context.db method to access the database, write data to the database that you created. And you can also write logs there. So once everything's working, you can go and look at GraphQL queries. We have a graphical playground. You can click through and just select the fields that you need. You can try the queries right there, debug the query. And then from there, you can directly export code to be used in the boss component. You can even change the query keyword to subscription keyword in GraphQL, and you will receive WebSocket connection with that subscription automatically. Let's try to look at the demo of how this works. So first of all, this is NEAR.org main page. How can you find Query API? You go to Applications, Develop, and find NEAR Query API. Here you can see different indexers that people build. There's one specific that I want to show you. This indexer is currently running. You can see the status. It shows the logs that the user created. You can see the current block height. You can see the status that it's running. Let's look at the code. This is written directly on NEAR.org as a widget stored on-chain. The editor experience is powered by a separate web instance because we wanted to produce as much, as rich experience for editing as possible. And here you can see the code that was written to extract the posts, the comments, and the likes for the main social feed. It all starts somewhere here. When we look at the block, we look at all the actions, we go through all the operations, we extract function calls and set methods. And you need to know this information. You need to know what to query. You need to know your own smart contract. But this is a key value storage on social.near, so we need to look at all the set methods. And then we're basically looking for posts and likes. And here, if we found a post, we run handle post creation, or we run handle comment creation, or we handle a like. And here, these are the functions. Let's say handle post creation. We assemble the post data, and we just simply context.db.posts.insert the post data. This is the schema that I showed you before. We have the posts table, we have the comments table. The cool thing is we generate types on the fly so that it's easier for you to write. So let's say you can type context.db.comments, and then you can say insert, and you can add the object that you need. The names of the fields are the same as in your schema. That makes access to the database easier. I just switched to the actual indexer that is running in production right now that powers the main feed. It's deployed under dataplatform.near. I wanted to quickly show the debugging experience. So let's say there is a block height where there is a post. We can actually take the post. I'm choosing a block, but let's say this block. In reality, when you're editing an indexer code, you need to use Explorer and look at the transactions of into your smart contract, and you need to find the blocks where these transactions generate receipts to your smart contract, and this is where you want to debug your indexer. But here, it's just handy for me here on the stage to find this block. I go to indexer, and I can switch on the debug mode and paste this block height here. I can press plus, open the console, the browser console, and just hit play here. And so what will happen is we will fetch the block, and we will execute this function right away in the browser. And everything that you're outputting, these are the logs that the developer output in this function. We will show it here in the console, and hopefully this will make it easier for you to troubleshoot the indexing on every single block that you have. We don't touch the database in this debug mode, so you cannot select and you cannot insert, but you can simulate the processing for every block very easily. Now let's look at the graphical interface. So here, if we switch off the debug mode, here I can create a query for the indexer that I just created. We have a bunch of tables here. we name them after the creator of the indexer, the data platform NEAR, and then social feed is the name of the indexer, and then the table that was created in the schema follows after that. So let's say I want to query the posts. I want to find 5 last posts. Last means I need to order by block height descending. And I want to take the account ID. I want to take the content. And maybe I want to look at the post likes aggregate, which means I want to know the number of likes that were under this post. So I just assemble this query. I can hit play, and I'm right away getting the indexed data from here with the latest posts. Now, what if I want to build a user interface with that? If you want to use it in the components on near.org, you can hit share icon here, which opens the code exporter. And right away here, you have the code that you can directly copy paste into Sandbox, which I will open here. So you can copy paste it here. And if you look at the preview, we're just rendering the JSON object, but you can put anything here. So for example, a.account ID will show us the account names that created the last posts, and after that you can implement your user interface. I have also the example of the widget activity feed that is a subscription. Hopefully somebody sends, let me refresh maybe, but while I'm talking, maybe somebody will edit the widget, and this user interface will automatically update because it maintains a WebSocket connection to Query API and shows live stream of all the edits to widgets. But it didn't happen. It doesn't happen very often. But you can check the code, and here you can look at the details of this component. And if you want, you can fork it. There is a bunch of styles, as always. It looks at NEAR Query API at pagoda.co. And here we have a bunch of code that is needed to maintain a WebSocket connection and update the user interface. All right, that's pretty much it for the demo and my presentation today. Query API is available in a beta mode where basically we need to add you to whitelist to use it because we don't want to we want to maintain the service for everybody and want to make sure that everything's stable. We'll just have a short conversation with you about your use case. If this is one of the smaller smart contracts and you don't need to index the whole blockchain, you're just building a dApp, we will give access to you and work with you to bring your indexer to production. You can use this QR code to fill up the form. We have 2 minutes. If you have any questions, I can answer them now, or you can find me afterwards. All right, I see people scanning the code. That's good. So see you around. Yeah.
What would be the best way to support a use case for something like Query API, but I don't want it to be publicly available? What contracts I'm storing? Would I need to use like your lake indexer just to know my own infrastructure?
So you don't want the Query API. You want to build Query API, but the API itself, you want it to be private. You want. Right. Well, Query API, everything's going to be public with the current setup. Query API is open source, so you can find it on under NEAR account in GitHub, and you can run a copy of Query API yourself. It's a bunch of Docker containers. You run them, and this will make a private API for you. All right. It's great to be on time. Thank you so much.